Welcome students. Today we are going to learn the modified distribution method, which is an optimality checking method in case of the transportation problem, in which we are going to first of all solve an example using the Wojcicki approximation method. Then we will proceed towards the modified distribution method. We have got an example. I will write it immediately here, and I got an example here. Got an example. I have got the sources A, B and C. I have got destination D, E and F. And here I have got the cost subsequence 4, 1, 3, 8, 7, 4, 4, 2, and here is supply. There will be demand. Supply is simply, all right, in the red, that is 50, 40, 60. Demand is 20, 95, 35, and I will see the supply is 150, demand is 150. This is balance and transportation problem. Now, when this is balance and transportation problem, simply what I need to do, I have to go for allocation using Wojcicki's approximation method. We know that's an iterative process. Iteration first. I will write here iteration first. My iteration first will be simply, I have to find out the difference between the between the costs of the cells as well as the rows. In this row, we can see that we have got 4, 6, 4 and 1. The difference between the lowest and the next highest, that is 1 and 4. The difference is 3. Here the between lowest is 3 and next highest is 7. The difference is 4. Here the lowest is 2 and the highest is 4. Next highest is 4. Then the difference will be equal to 2. And here from the columns we can see here is 1, this is 2, and difference is 1. Difference between 4 and 4, we know these are the same. The highest, the lowest one is same, and the next highest, that is also the 4, they are the same. The difference will be equal to 4 minus 4 will be equal to 0. And now in this case, the lowest is 3 and next highest is 4. 3 minus 4 is equal to, then the difference is equal to 1. Remember one thing, these differences are always taken as simply the numeric differences, not showing the sign as whether positive or negative. Simply we have to take the difference. Now the highest difference is here. We know after doing this we have to choose the highest difference. The highest difference here, that means this is corresponding to the column B. Now I have to allocate in the column B. Why I have to allocate in these 3 cells? In these 3 cells, I have to choose the cell which has got the least cost. Simply that is this cell, it has got the least cost. How much I can allocate to it? As we can see from here, D has got demand of 20, while as B can provide him the 40 items. Now we know it can take only 20. Now this 20 will cut and this will become 0. D's demand has exhausted, and here we have got remaining 20 items. Now after that we have to follow the same procedure. We will go for the iteration second. In case of second iteration, the difference in this row is also there 3. Second row, simply this column, we can say the D column, the demand of the D column has already exhausted, so we don't have to consider the D column. Simply we will consider only column E and F. Here we have seen the 1 and 4, difference between 4 and 1 is 3. Now here the difference between 8 and 7 will be equal to 1, and difference between 4 and 2, here we can say 4 and 2, we have only 2, 4 and 2, E and F, the difference is equal to 2. But in this side we can say we have on all the three column, all the three item, we can say the cells in this column. This and this, the difference between this is already which we have given, this is 1, 2 and 1. Now the difference between 4 and 4 is 0. In this column, wait, I don't have to find any kind of difference between the, because the demand of this we can say the column is already met. Now we can see in these differences, in these penalties, the highest penalty is here, the 3. Now that means we have to allocate to this row. In this row I have got only two cells available, that is this and this. Among them I have to go for the least one. Least one is this one, which has got the lowest. How much I can give him? The A can provide him 50, while as its demand is only 35, it can take 35 out of 35. That means I will give him 35, and here the remaining will be 50. Now it is done. Now we have to we will look at the F station. The F station, the demand of the F station has altogether exhausted. There is no demand for the F station. Now we have got only station E, where all the three routes are presently, we can say they are available. Now we will see to whom we are going to allocate. Now we don't have to go for the iterative process here, because we have got the choice is clear. We have to allocate to the destination E. Now to whom destination E has got three routes. From which route we have we have to select to allocate the these we can say the allocate the demand, allocate the items. Now first of all we can see here the we know we have to go for the least cost. The least cost is 4, that is here in this cell as well as in this cell. Now among these two cells, which cell I have to consider for the allocation? The rule is that if we occur a try in the least cost cell, then we have to find that cell through which the maximum demand will be exhausted. We can see, if we will consider this one, A can provide him only 15 items. That means 50 items can be shipped from this route, while as in case of this cell, C can provide 60 and 95, and E has a demand of 95. That means maximum allocation can be done through this route. That means I can give 60 out of 60. Here will be 0, and 95 minus 60 will be equal to 35. Now again we have to find, we have got two cells, 4 and 8. In two cells, which I have to allocate, which cell I need to allocate. I know the least cost is 4. Now I have to consider simply the 4. Now how much it can take? 15 articles. It can take 15 items. When it will take 15 items from here, the items will be remaining 0. Here it will convert to 35 minus 15 will be equal to 20. Now I can see this cell will take 20 items, because here is a demand. Now it will be equal to 0. 20 minus 20 will be equal to 0. Now this is the simply allocation of this transportation problem. Now I will show you the total costs of the transportation. Here transportation costs we can see. These are calculated as like this. The allocated cells: 4 into 15, 1 into 35, 3 into 20, 8 into 20, and 4 into 60. Now I will write them. You can simply copy it from there. It will be 4 into 15 plus 1 into 35 plus 3 into 20 plus 8 into 20 plus 4 into 60. Now the total transportation costs will be equal to 60 plus 35 plus 60 plus 160 plus 240. That will be equal to 555. Now remember this, our total transportation costs are 555. Now considering this problem, we have to use it. We have to go for this was simply the initial basic feasible solution. We can say it's a basic feasible solution by using VAM, modulus approximation method. Now we will take forward this example for modified distribution method to find out the optimality check. Before proceeding to the optimality check, what we have to do, simply we first of all we have to check whether the solution is degenerate or not. We know how to check the degeneracy of the solution. We know n should be equal to m plus n minus 1. What is n? This is number of occupied rows or cells. M number of columns, or we can simply say the rows. N number of columns, and 1 is numeric 1. Simply when we will check in this example, we have got number of occupied cells. For example, I will check here. I have got 1 2 3 4 and 5. That means we have got 5 is equal to how many columns? 1 2 rows 1 2 3 columns 1 2 3. That is 3 plus 3 minus 1. That means 5 is equal to 5. This condition is satisfied. Now we can simply say this is not degenerate solution. When this is not degenerate solution, we can simply proceed for optimality check. We can simply proceed for optimality check. Now, in case of the optimality check, we have got two methods. One is stepping stone. Stepping stone method, and second one we have got modified distribution. Modified distribution method. We can call also MODI method. Stepping stone method is an iterative process, that is simply hit and trial process that we don't have to discuss in our syllabus. We have to go only for the one method, that is second, that is modified distribution method. Now we will check the optimality for the given example by using modified distribution method. For that I have to rewrite my matrix. A, B, C, D, E, F. I know. I got the costs here 6, here 3, 4, 4, 8, 4, then 1, 7, 2, and allocations I have already done that. That is here we got 15, 35, it is 20, it is 20 here, and we got this cell, allocated cell, that is 67. The cells in which we have shown the demand in the red, those are called as the allocated cells. Now we have to go for, we can say simply, the modified distribution method. To go for the modified distribution method, what we require to do is simply, I will write also the demand and supply here. It is supply, and this is here demand. I got the demand, here is the demand of 20, 95, 35, and here we have got 50, 40, and 60. And it goes down. Now we know. Before proceeding to the modified distribution method, what first of all I need to do is simply I have to allocate some numbers. For example, I will allocate UI and VJ. What is this UI and VJ? UI represents rows and Vj represents column. Now what's rows and what's column, which I am going to show you. For example, in case of simply what we need to do is I have to give arbitrary. I have to start from the UI. For example, for rows I have to calculate UI, and for columns I have to calculate Vj. Simply I will write here, this is simply the, I will write here, this is UI. I have to calculate from there, I have to calculate the UI, and from this side, from the lower side, I have to calculate Vj. What is UI and what is Vj? Simply I have to use a formula that we called simply as, that is our Cij should be equal to UI plus Vj. We know what is Cij. This is cost of cell, and UI, this is cost of row, and this is cost of particular column. Sorry, it's here. This is cost of cell, this is cost of row, and this is cost of particular column. Now what we need to do, I have to follow this formula, and I have to allocate in all the rows and all columns. I have to calculate UI and I have to calculate Vj. Now how to calculate UI and Vj? We know presently we don't have got any values of UI and Vj. Now I have to start from the first cell. I will allocate arbitrary, I will allocate simply to this row A, I will allocate UI equal to, as per rule, equal to 0. I will allocate it UI equal to 0. This is simply the rule. Now I have to find, now this column A has got UI is equal to 0. Now I have to calculate Vj's for all the three columns G, D, E and F from this UI which I have already given. Now how to calculate? Remember to consider, these are the costs of cells. Which cells? Allocated cells. Allocated cells. Consider the allocated cell. For example, in this row I have got two allocated cells, that is this and this. Now calculate for this row, for this column and for this column. I know for example this column, for this very column I have got UI equal to 0, Cij is equal to 1. For this column, for example, I will go for this column. For example, I know my UI is equal to, here I will calculate my UI is equal to 0 and Cij is equal to, Cij is given, that is equal to 1. Now I have to calculate Vj. Simply use this formula, Cij is equal to UI plus Vj. That means here in this question I will simply write here my Cij is 1 will be equal to UI is equal to 0 plus Vj, which I have to calculate. This 0, that means UI plus 0 is nothing, that means Vj will be equal to 1 in this very cell which I am showing. Now that means Vj I have to write from this side, this the Vj will be equal to 1. The Vj of this cell will be equal to 1. Now after that what I need to do, I have to go likewise for all the occupied cells, for all the occupied rows. Now I have got second occupied root here, that is 4. UI is equal to 4. Cij for this will be equal to, sorry, UI is equal to 0, sorry, I'm sorry, 0. Cij is equal to 4 and Vj I have to calculate. Simply I know Cij, that means 4 will be equal to 0 plus Vj. When there is nothing, that means Vj will be equal to 4. For this very column Vj equal to 4. Now this is done for this column. Now I have to go for only, now here I cannot allocate because this is not occupied cell. Now I have to go through the next occupied cell. For example, I have got this occupied cell. Why I will consider this occupied cell, not this one? Because Vj is given here, the UI is not given, so I have to go accordingly. Where Vj is given, I have to calculate the Uj of that row, and in those rows where Vj is given, I have to calculate the Vj of that row. For example, in this row, in this column, I will write here, it is Cii is equal to 8 will be equal to, Cij is 8 will be equal to, Uj is equal to, I don't know, Uj I have to, Ui I have to calculate, plus Vj is equal to 4. When 4 will come here, 8 minus 4 will be equal to Ui. That means Ui will be equal to 4. Ui will be equal to 4. Now I have calculated the Ui of this, I can say of this row. Now I can, this is the another cell which is occupied in this row. Now I can calculate the Vj of this occupied cell. How I have to calculate? Uj is given and Cij is 3. That means 3 will be equal to, Uj is 4 plus Vj. I know when 4 will come here, 3 minus 4 will be equal to Vj. That means Vj will be equal to 3 minus 4 is equal to minus 1. Here will be equal to minus 1. If it is minus, I have to write. If it is plus, I have to write there. Sign is matters here. Now I have got, when I am calculating to this row, I know already from this side I have calculated for this column, Vd column, this is 4, Vj is 4. I can calculate for this occupied root, that is the, I can calculate, say Cij of this occupied root is equal to 4. I know Cij equal to Ui plus Vj. Cij for this row will be equal to 4 is equal to Ui is not given, which I have to calculate here, plus Vj is 4. 4 will come here, 4 minus 4 will be equal to 0. So this row has got Uj equal to 0. Ui equal to 0. Now if you can see from here and from here, I have given Uj and Vj, I have calculated the Ui and Vj values of all the rows and columns. Now what I need to do after this, what I need to do, simply what I have to do now, first of all, in this formula I have considered only those cells which are occupied cells. Now we have got the another formula for unoccupied. This is for, if I can say, this is for occupied cells or roots, and this is for unoccupied or roots. Now for unoccupied cells and roots, what I need to do, simply what I have to do, I have to calculate del Ij is equal to Ui plus Vj minus Cij. For every unoccupied cell or roots, I have to calculate del Ij. Del Ij is equal to Ui plus Vj minus Cij. Now let us calculate the first root, which is here given, this one. For this root, let us calculate this del Ij for this root. I will calculate for this root. This root is root A D. Root A, if I can name this root A and D. For this, del Ij will be equal to, which I need to calculate, will be equal to Ui. What is the Ui of this row? That is 0. Plus, what is the Vj of this row? That is minus 1. 0 minus minus 1. Now minus Cij of unoccupied cell, that is equal to 6 minus 6. That will be equal to minus 1 minus 6 will be equal to minus 7. Del Ij will be equal to minus 7. Now if it is minus 7, I will write here a small, this is minus 7. This is minus 7. You can see. Now I will calculate to my next cell, next unoccupied root. That is, this is my what one? That is this one, BF. We will calculate for BF cell. My del Ij will be equal to, simply I have to calculate del Ij of this root. Simply tell me what is the Ui of this cell. That is 0. plus what is the Vj? That is 1 minus Cij. How much is Cij of this root? Sorry, it is not 0. This is 4 here. I messed it up. I messed up this with this row. Actually, this is this. This is 4 is ui plus Vj is 1 minus will be Cij. Cij is 7. Now that will be equal to simply 4 plus 1 is 5. 5 minus 7 will be equal to minus 2. Now I have to write here minus 2. After that, I will calculate another row is this CD. This is this is the root CD. Root CD. For root CD, I have to calculate del ij will be equal to, what is ui of this root? That is 0. What is Vj? That is minus 1. Minus 1 minus the cost is 4. Cij 4. Minus 1 minus 4 will be equal to minus 5. That means this row has got minus 5. It is del ij. Now I have got only one row left, that is CF. Row CF. In case of this root CF, I have to calculate del ij. Del ij will be equal to ui is 0 plus Vj is 4 minus del ij Vj, that will be simply equal to 4, that will be simply equal to 0, and 4 0 minus that will be simply equal, minus will be equal to, sorry, not to this row, I have to calculate for this row. I am taking it wrong. This is 2, this is sorry, I am making it wrong. Del ij will be equal to 0 plus 1, Vj is 1, minus will be equal to 2, that will be equal to minus 2. Done. It's done. You can say I have written here minus 2. Now to check for the optimality, first of all, if the del ij, what I have to see, the del ij, if the del ij of all unoccupied roots is equal to negative, then the problem is called as simply this is optimal. We do not need to further optimize it because there is no room to optimize it. That means we have just, I have seen you that we have got the costs of one, which I have cost as a transportation cost, that is 555. This is the lowest transportation cost which I can achieve from this very problem by using the Modi method. There is no further, we can say, further reduction in the costs. And remember the rule, if del ij is negative, then the solution is optimal, or if del ij is 0. If del ij is 0, that means the solution is still the optimal, but that is not unique solution. That means the solution can be, for example, we can simply say there can be another solution, but the costs will be same, 5, 5, 5. In case of the unique solution, the costs are always equal to same, but the allocated roots can be different roots, but the costs will be equal to same. But now if del ij is positive, which is not in our case, if del ij comes out to be positive, then what we need to do is simply we have to optimize that solution. That means we have to actually follow the Modi method, which I am going to show you in the next problem. Thank you very much.